Okay, so today's lesson continues with what we've been talking about, the slope and the y-intercept. The good thing about today's lesson is most of this was previewed yesterday. Okay, I didn't have to teach you all the y-intercept stuff yesterday, but by doing so, you're kind of ahead of the game. So some of this will be for review. Those of you who weren't here yesterday or are watching the video because you're completely lost, then I'll kind of catch you up here, okay? I'm going to talk about all this stuff like we've never talked about it before. All right, so the first thing was slope. We spent a lot of time on slope, probably 2 weeks at this point. All right, that's our rise over our run, change in y over change of x, y2 minus y1, x2 minus x1, all these different ways of solving slope we've already done, okay? So most of our focus today will be on this y-intercept. The concept of the y-intercept is really not that tough. Right? It's where we intercept the y-axis. Okay? It's good to be able to recognize this immediately because this is our starting point. This is our initial value. In fact, they say that. Where is it? Well, they might say it in a little bit. Basically, it tells us here that the graph of every non-vertical line crosses the y-axis. Okay, if you have a vertical line like this, let's say it's x equals 3. We talked about that before. That is an undefined slope. Okay, undefined slopes, unless they're on the y-axis, do not cross the y-axis. They're parallel with it. Okay, those are the only lines that do not have a y-intercept. Every other line, whether it's a positive slope or a negative slope, it's eventually going to cross this y-axis somewhere. Okay? If it crosses through the origin, then our y-intercept is 0. Does that make sense? We're crossing the y-intercept, or the y-axis, at 0. Okay? The y-intercept is the y-coordinate of the point where the graph intersects the y-axis. Okay? That's what we just basically said. Now, here's the good point. The x-coordinate of this point is always 0. Okay, if we think of how a graph is constructed, you have your x-axis, you have your y-axis. That vertical y-axis here, that happens right where x is 0. Okay, that y-axis goes up through x at 0. Okay, so when we're crossing that exact point, our x is always going to be 0. We're not going to go left and right. We're going to go straight up and down to our y-intercept. So if we're looking at a table, and it's x and y, and x is 0 and y is 5, I know right away that's my y-intercept. Okay, so that's a good rule of thumb to know. It's going to help you out on some of the papers that we're going to be doing in here. Okay. So the first thing we look at here, I'm going to go ahead and zoom in on this table here. We need to be able to go from a graph into y equals mx plus b. Now what does our m represent? Our slope. All right, and b is the y-intercept we were just talking about. The easiest thing to identify right off the bat is our y-intercept. What's our y-intercept here? The 4. We're crossing the y-axis. This is the y-axis. We're crossing it right here at the 4. So that's our y-intercept. So it's going to be plus 4. So now we just got to figure out what goes in front of our x. All right. We need to identify any point that will work. Now these 2 points were already identified for us, but you can also see this goes right through the corner. That goes right through the corner. And right here we go right through the corner. So to find our slope, it's the rise over the run. We went down 2 and right 3. Down 2, right 3. Down 2, right 3. Down 2, right 3. So, -2 is our rise. 3 is our run. Someone's cell phone's going off. So embarrassing. All right, so our rise was -2, our run was 3, so -2 over 3. This is our equation here. Okay, that's working from a graph into our equation. We're going to do some assignment today that we will be doing that. Okay, identify your y-intercept, then identify your slope. Okay, now on this particular example, they already had the equation done for us right here. Okay, now in order to go from the equation to the table, okay, I know the line's already drawn, but we're going to go ahead and I'm just going to walk ourselves through it just in case. The first thing I recognize is my y-intercept is 4. So that's going to be the first point that I would make. From that point, I would start using the slope. I'm going to go down 2 and right 3. All right, and if I followed those rules, I'll end up getting the line that they already have drawn. Does everybody see that? We end up right there. Now, that's how you do it the old-fashioned way. Now, I showed you guys on your graphing calculators, which, of course, if you're watching this at home, you probably don't have a graphing calculator unless you bought one, which is probably a good idea. But if you didn't, that's okay. If you have a graphing calculator at home, you can hit the y equals button. You can type in all of that mess, and then you can say second table. And it'll bring you to a table that will show you every single point on that line. And you could go make a little mark on every single coordinate and draw your line that way. Okay? So the calculator will actually show you how to do every single point, which makes your life that much easier. All right? So, if we go to the next page, you can see here, this is where they're going to start teaching you the slope-intercept equation, but we've already talked about it quite a bit. All right? I've already introduced you to it. Y equals mx plus b. This is actually given to you on your star formula sheet. They write it out for you, but I promise you by that time you're going to already have it memorized because we use it so much. Okay? So, what we need to look at is if they give us word problems. Okay? So I'm going to walk us through this particular word problem. It tells you that you work at a telephone store. And at this telephone store, you earn a paycheck no matter how many phones you sell, but you also earn commission on cell phones. So the more cell phones you sell, the higher your paycheck is going to be. Okay? So, first thing you have to be able to do is identify your X and your Y. All right? X is always independent. Y is always dependent. Okay? When I say Y is dependent, I mean to get your Y, it depends on what your X is. So if we're looking at this example, weekly income is going to be our Y. Because the money that you're paid depends on how many phones you sell, right? Okay? So, your income depends on the phones sold. So your dependent variable is Y, that's your money. Your X is your independent variable, that would be the phones. Okay, so once we have that identified, now I can use this to solve for my slope. Remember, slope was change in Y over the change in X. So these are my Y's. From 480 to 630, and 630 to 780, and 780 to 930. Do the subtraction on your calculator. Tell me what the change is. It's obviously going up. It's not going to be a negative. But from 480 to 630. $150. Y'all are scared of being on the camera, I can tell. $150. All right, so every time our change in Y was $150. Now what about our change in X? It's going up by 10 every time. All right, so my change of X is 10. Now what's 150 divided by 10? 15. So I know that my M, my slope, is 15. 15x. All right. Plus, now I got to get my B, my y-intercept. Now, what is my x at my y-intercept? What is the value of x at the y-intercept? 0. Good. So, in order to go to 0, I had to go back how many times? 10. So, how many times am I going to go back on my y? 150. So, what's 480 going back 150? 330. Good. So, that would be my y-intercept. Okay. Now, there is a method of just plugging that table into your calculator with the stat edit, and then doing the calculate the linear reg. That's one of the things that we learned yesterday. And the calculator would give you that equation for you. You really wouldn't have to worry about it. But assuming you've forgotten how to do that, okay, it's good to know how this works. Now, one thing we need to be able to understand is what these formulas are telling us. All right, what this equation says. All right, now I told you, you got paid so much per phone sold, and you got a weekly salary no matter what. Which of these numbers in this equation is your weekly salary? You're going to get it no matter what. Well, it's not 130. 330. 330 is added on no matter what, right? Whether you sold 0 phones or 8 million phones, you got $330. It's added on to the end. Okay, that is our constant. That's your constant paycheck. Okay, how much are you paid per phone? $15. Every phone you sell, you get 15 bucks. Okay, so if you sold 1 phone, you do 15 times 1 plus 330. It'd be $345. Okay, that's a real world application to some of these linear equations. All right, if y'all ever go work at the Buckle, they work on commission. That's why when you walk in there, they're like, "Can I help you? Can I help you?" Because they want to make that money. All right, so there we go. All right. Now here's another table. Now again, you could use your calculator. That's fine. Okay, and you'll get the same thing that we're about to get. All right, but change in y over change of x. Here's my y. How much is it changing every time? 10, 10, 10. So change of y is 10. How much is my x changing every time? 2. 10 over 2 equals 5. That just means 10 divided by 2. So we have y equals mx plus b. So y equals, we now know the slope is 5. All right, now we just need the y-intercept. So if I go back to 0, what am I going to get for y? 12, because I got to go back 10. All right, so my y-intercept is 12. Okay. Here we go. All right. What's my change in y every time? From 8 to 15, 15 to 22, 22 to 29. 7. Every time it's going up by 7. Good. Change of x? 1. All right, so my slope would be 7 over 1. So y equals 7x plus, if I go back 1 to 0, how much am I going to go back here? 7, and that would give me 1. There we go. Again, if you remember the stat function in your calculator will do all of that for you. Probably takes about the same amount of time, but it's a little bit easier on the calculator and you don't make math mistakes. All right, we're skipping that page. Okay, so let's really look at some of these.
Are we doing this today?
All right, what is the y-intercept on this graph? 1. Crosses at the 1. All right, now for slope, now I see that it gives you 2 points. But again, we need to be able to recognize that that's a good point, that's a good point, that's a good point. All of those are good points to use. So, rise over run. How much am I rising? Am I going up or down? I'm going down how many times? 2. Down 2 and over 1. All right, down 2, over 1. Down 2, over 1. So negative 2 is my rise. 1 is my run. So negative 2 is my slope. Okay. Number 2 is going to try to confuse you because of the numbers on the y-axis. Don't let it. What is my y-intercept? Good. They're counting up by 5s, right? So the y-intercept is negative 15. Now, again, all of these are good points to use. So how much is it going up? It's going up 1 block here, which is 5, because we're counting up by 5s. And then it's running how many times? 1. So 5 over 1, which equals 5 as our slope. So this particular problem would be y equals 5x minus 15. Or y equals 5x plus a negative 15. Either way, it's the same thing. Number 3. What's my y-intercept?
2.
Close.
2.5.
Negative 2. All right. Now, I can see that's a good point. I can see that's a good point. That's a good point. That's a good point. All right. So, how much do I need to rise?
1. Oh, no. 2. 4.
All right. So I heard 4. All right. That would be 1, 2, 3, 4 up here. That's too much, right?
3.
All right. So yeah, it's going to be 3. 1, 2, 3. And then how much do I run?
2.
1, 2. All right. Up 3, over 2. Up 3, over 2. It works every time. So the rise is 3, the run is 2. My slope is 3 over 2. Okay. Number 4. What is my slope or my y-intercept here? 9. Good. This time it's counting up by 3s. So that would be 3, 6, 9, 12, 15. All right, good. So, again, all of these are going right through a corner, so these are all good points. So what is my rise? Negative 3. We went down 3 and over how many times? 1. Negative 3 over 1, which is just negative 3. Good. All right. Number 5. You should be able to look immediately and tell what is the y-intercept? 1. X is 0 when y is 1. Okay? Slope is the change in y, which is 6, over the change of x, which is 2. What does 6 over 2 equal? 3. Good. Excellent. All right. What's my y-intercept? 140. Good. 140. All right. And then my change in y was 20. My change in x was 5. I'm sorry, it's a negative 20 because we're going down. So negative 20 over 5. Anyone know what that equals?
No. Negative 20 over positive 5. That equals negative 15. No, negative 25. No.
Negative 20 divided by 5.
Is it negative 4?
Negative 4. There it is.
Trey.
Okay, good. All right. We're going to do a couple more word problems here. Now, I'm going to skip the actual word problem themselves. I'm going to go straight to the equation here. Obviously, we could throw all of this in your calculator again, but it's still good to know how we're doing this. So, first thing we're going to figure out, let's figure out the slope. All right? The cost is our y, the rooms cleaned is our x, because the cost depends on the numbers of rooms that are cleaned, right?
Yep.
All right, so it makes it a dependent variable. Now, how much is our y changing every time?
50.
Good. 50, 50, and 50. How much is our x changing?
1.
1, 1, and 1. So, our slope is going to be 50 over 1, which is just 50. Y equals 50x plus, okay, if I took x back to 0, what is my y going to go back to? 75. Good. Very good. Okay. All right, now, cost is our y, hours is our x. The cost of this paddling boat depends on how many hours you rent it for. Okay, now, what's my change in y each time? 12, good. My change of x is 1. That's not our bell. All right, so that means y equals 12x plus, if this was a 0 and I went back 12, I'd be at 5. Good. Y'all are killing it. Okay. Last examples here. All right. We've got, we'll call, I don't remember what the word problem is. I'm just going to say, we got guitar lessons. Just guitar lessons that you're going to go to. Now, you can either go to group lessons or private lessons. Okay, and this is the table that's provided. So we're going to come up with the equation for group lessons and the equation for private lessons. So we'll do group lessons first. All right, so y equals, all right, these are going to be our y's because the money depends on the number of lessons. So what's my change in y with group? 30 every time. It's 30, 30, 30. And what's my change of x? 1. And 1. And 1. So 30 over 1, which is just 30. Plus, if I went to 0 lessons, yeah, it would go down to 25 because we're counting up by 30, so we'll count down by 30. Good. So 30x plus 25. That's the group lesson. All right. Now let's look at private lesson. What's my change with the private lesson? Good. 50, 50, 50. All right. I keep hitting that with my wrist. All right. And now my change in x is still 1. So it'll now private lessons will be y equals 50x plus, what happens? What is it? 25. Good. Now, we need to be able to analyze these. All right? So, you're paying somebody for lessons. Okay? What does the plus 25 on each one tell us?
To add.
We're adding 25, no matter what. So, what does that tell us?
That's the starting.
That's the starting fee. No matter how many lessons you take, you're going to pay $25 just for talking to the guy. Okay? Or girl. Girls can teach you guitar. So, just by starting your lessons, by saying I want to take lessons, it's going to take $25 to get it going. Now, which one of these is cheaper? The group or the private lessons? Group. How much does group cost per lesson? 30. How much does private lessons? 50. All right, that's per lesson. So if you're going to go private, that's going to be $20 per lesson more. Okay?
So if you go private, it's going to be
All right. Okay, now that is our rundown of going from tables and graphs into a y equals mx plus b equation. Okay? You need to be able to do the opposite, which is kind of what we worked on yesterday. All right, and you're going to work on it a little bit more here in a little bit. Okay?